Hi everyone, welcome to my channel. Today I will show you how to wireless communicate between two IoT devices. In this project, we will build lights that can sync together wirelessly by using the MQTT protocol. Through this project, you can start learning about the Internet of Things and the way IoT devices communicate with each other. If it is new to you, don't worry, because I will do it step by step. Let's get started. What is the MQTT protocol? MQTT Message Queuing Telemetry Transport is a lightweight messaging protocol designed for efficient communication between devices in the network. It follows publish subscribe model, where this device can publish messages to specific topic, and other devices can subscribe to those topics to receive messages. All we need are two IoT devices. Here I use the ESP32 board and the ESP8266 chip. One MQTT broker is known as the MQTT server, to which two of our devices connect. 4 LEDs, 4 buttons, breadboard and wire for connection. First, we must create an MQTT broker by signing up for a HiMQ account. We will search for himq.com and then click on the cloud icon. You have many ways to create an account, like by GitHub or Google. Here I use Google to create an account. We need to fill in some personal information to sign up. Fill in your name. In subtitle, you can choose one of them. Anything goes because it doesn't matter. The same for company. This is the first MQTT broker. It's created automatically when you sign up for a new account. Now you need to create credentials for your MQTT broker. Next, you need to create a topic in the MQTT broker, because one broker can include many topics, so we can easily control. We search for HiMQ WebSocket client. We type the user and password just create to connect to your broker. You need to name your topic, then click on the subscribe button to add a new topic. You can tag the broker by using the public tab here. Type your topic into the topic row and type the message that you want to send to your IoT device subscribed to this topic. You see the message just published below. Second, we start programming for the ESP32 board. We need to create a new project. Give the name for your project. Next, select the board that you are using to make this project. Here I choose ESP32 DevKit V1. I remove the checkbox here because I want to save the project to another place where I can find it easily. After done, click on the Finish button to create new projects. It will take a while to create. We only need to pay attention to two files, main C++ and lifefile we need. You see the board you choose will be defined here. In the main C++ file, the Arduino library, setup and loop function is required. Make sure you don't delete them. Now, we must import the Wi-Fi library for our IoT device can connect to the Wi-Fi. Next, we import the PubSub client library to connect with the MQTT broker. But because this library isn't available in this environment, we have to install it. To install, we will open the PIO Home tab and choose the library on the sidebar. We search for MQTT. Make sure you choose exactly this library. Click Add to add this library to your projects. You see, this library was just added here. Now, you need to define some concepts about Wi-Fi like address ID and password of your Wi-Fi. We will release this available function because we don't need that. Serial begin. Perhaps we can bring the value out of the stream. Don't forget to define the monitor speed in the platform IO init file. Let's create a setup Wi-Fi function to connect with the Wi-Fi. Bring the address ID of your Wi-Fi here. Use the begin function with two parameters, address ID and password, to initiate the connection. In the while loop, we wait for a successful Wi-Fi connection if it's not already connected. Finally, we will ring the notice connected successfully. We call the setup Wi-Fi function here. Next, you need to define some of your MQTT broker information. Link up the broker, port, user, password, and topic. We continue to define 4 pins to connect with 2 buttons and 2 LEDs. Next, we will define the mode for every pin. I use input pull-up for 2 button pins because I want to reduce noise for the buttons. And output for the LED spin to control 2 LEDs. We need to set 2 LED spin to low to make sure 2 LEDs is off when the MCU starts. We need to create the Wi-Fi client object for the client object in the pops-up client class to use to connect with the MQTT broker. Next, we will create a function to connect with the broker. First, we check if the client is not connected with the broker. If no, MCU will initiate the connection. We modify an ID differently for every IoT to make sure the MQTT broker can work exactly. Second, we check if the client connected with your broker by client ID, user and password or not. If yes, we need to supply exactly to the topic which you have just created. After that, we will bring to the monitor to node successfully connected with our broker. If not, we will try to reconnect. We have to create a callback function to receive the message from the topic we supply to, but make sure that the parameters are exactly like this. Because this function is called from the PubSub client library through the function pointer. If you change this function like the data type of parameters, this function cannot work exactly. In the setup function, we need to some step to finish setup like set server and set compact. In set server, we need to clean up the server and port. In set callback, we need the rest of the callback function here. Now, we continue to program for the logic part. We need to create 4 variables, 2 variables to say the set of 2 LEDs, and 2 variables to say the value of 2 buttons. Next, we need a function to toggle the state of the LEDs every time we press the button. In this function, we check the present state value is true, which means the LED is on. So we toggle the state to off and update the present state of the LED through the pointer. Otherwise, we toggle the state to on. In the callback function, we will decode the payload to decide what LEDs are on or off. Here I assign number 3 for LEDs 1. And number 4 for LED 2. We will toggle the state of the LEDs corresponding to the payload. Besides that, we also need a function to send the present state of LEDs to another IoT device. Next, we will program for the main loop function. We must place line group here to maintain the connection. And check the connection with the MQTT broker. If the connection is stopped, we have to reconnect immediately to keep everything can sync exactly. I use the pull loop technique to check the state of two buttons. It can detect 100% every time you press a button, but it is simple. If which button is pressed, we will toggle the LEDs corresponding with that button. And send the state of that LED to another IoT device. Note that you should not use the same number as the number in the callback function, because the device sending this message also receives this message from the MQTT broker. This thing results in LEDs don't work like what we want. Now, we finished programming for the ESP32 board. Let's upload the code. To upload, you have to find out the port of the ESP32 connect to your computer. You can right-click on this button icon, then choose Manage. Next, choose Device Manager. If you do not yet connect the ESP, you can see the box here. Let's plug in it, and you will see the page will reload. Now you can see the port here is COM7. Pay attention to the CB210X or CX340 to find this port easily. After you find the port, you need to declare here with the key upload port. Click the upload button to upload the program to the ESP32 board. Let's reopen the IMQ WebSocket client to test the program. You see, when I press the button, the message published below is immediately. Otherwise, when I publish the message here, the IoT device can also receive. Finally, we will do the same for ESP8266 chip with a new project. And choose the ESP8266 chip. Because they are mostly the same. So I copy this and paste it in here. But we need to change the Wi-Fi library to the ESP8266 Wi-Fi.h. Next, we change some pin because they had a number of pin different. And don't forget to change the client ID for the new IoT device. In the callback function, we need to perform the reverse of what was done with the ESP32. The number to publish also need to be changed. Now, do the same to Fireball, and then upload the program to the ESP8266 chip. Now everything is done. Let's set LED scenes that wirelessly together between two IoT devices. Thanks for watching the video. If you like this video, give me a like and subscribe for more.